Welcome to the Walton Pi. Today we're going to be talking about derivatives of exponential functions. Just like polynomials, these come up fairly frequently, and so we are going to be trying to figure out if there's a general rule for how we can find the derivatives of them. So if we start with f of x equals a to the x, we want to figure out what is f prime of x. We're going to go through that limit definition. So f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h, which becomes a to the x plus h minus a to the x all over h. We can pull out an a to the x from everything, and we're left with a to the x times a to the h minus 1 all over h, and we're just taking that as the limit as h goes to 0. And so what we have found is we can then pull the a to the x out, and we get the limit as h goes to 0 of a to the h minus a to the 0 all over h. Now that is very special because that is just the limit definition of the derivative at a point, and so that is the derivative of f at 0. So that is whatever the derivative of a to the x is at 0, that's going to be what we multiply by a to the x. And so that tells us that the derivative of exponentials is just the exponential times some extra constant, which is specifically the derivative of f at 0. The constant e, so that is Euler's number, that has a very special property. It is the unique constant where the derivative of e to the x at 0 is defined to be 1. That's how we created it. So the derivative of f of x is e to the x because it's e to the x times 1. And so that tells us a way that we might be able to approach figuring out what's the derivative of a generic f of x equals a to the x. So we already know that the derivative of f of x is going to be a to the x times the derivative of f at 0. So we just need to figure out what's the derivative of f at 0. So we can rewrite a to the x as e to the natural log of a raised to the x. So that means that we can go through and rewrite the limit as h goes to 0 of a to the h minus 1 all over h. We're going to start by replacing the a with e to the natural log of a. So that becomes the limit as h goes to 0 of e to the natural log of a times h minus e to the 0 all over h. At this point we need to try and figure out a way to rewrite this, so we're going to multiply the top and bottom by the natural log of a. The reason we chose to do this is because we had e to the natural log of a times h, so we are wanting a natural log of a times h on the bottom as well. So that's why we had to multiply both the top and bottom by the natural log of a. If we pull the natural log of a out to the front from the top of the fraction, we get the natural log of a times the limit as h goes to 0 of e to the natural log of a times h minus e to the 0 all over natural log of a times h. At this point, we are going to do a u substitution, where we are going to say that u is equal to h times the natural log of a. What this is going to do is this is going to turn this into a limit, again, of a form that looks a lot like the derivative definition. So we get the natural log of a times the limit as h goes to 0 of e to the natural log of a times h minus e to the 0 all over the natural log of a times h. If we make the substitutions, we now get the limit as u goes to 0 of e to the u minus e to the 0 all over u. The reason for that is as h goes to 0, u will also go to 0, because the natural log of a is just some constant. So we get the natural log of a times the derivative of e at 0, or e to the x at 0, which is just 1. So that is why we are getting the natural log of a is the derivative of a to the x at x equals 0. So that tells us that the derivative of f of x equals a to the x is just going to be the natural log of a times a to the x. So to summarize what we just covered, that means that the derivative of a to the x is equal to the natural log of a times a to the x, and the derivative of e to the x is equal to just e to the x. I hope this video was helpful and that it helps you to understand the derivatives of exponents a little better. Please like and subscribe if you haven't already so I can continue to make these sorts of videos. Have a great rest of your day and good luck with the rest of your math.